pH and hydrogen ions. So just a summary of what we have. We calculate the pH by taking the opposite of the log of H. And H is the concentration of hydrogen atoms in molars. All right, so for part A, we're given that tap water has a hydrogen ion concentration of about 10 to the power negative 6.65. So we're given the hydrogen concentration. So this right here is my value for H. So I'm just going to plug it in to get the pH. So the answer for this one here is going to be whatever the opposite of the log of 10 to the negative 6.65 equals. And if you plug that in your calculator, you should find, we'll do this together, that the answer is 6.65. And I'll explain why I knew that without a calculator in just a sec. So calculator, and again, remember way back from when we started logs in the first place, log with nothing written on the bottom is log base 10. So for this one, I want to know what's the opposite of the log of 10 raised to the power negative 6.65. And the calculator, oops, from parentheses place, says it is 6.65. And notice again, 6.65 in the answer matches the 6.65 on the power, but we lost the negative sign. So two reasons that happens is think back to what a logarithm is, and remember a log is an exponent. It tells us what power we need to get a certain result. So this right here, when I say what's the log of that number, says what power would you raise 10 to get this number? Well, obviously it would be 10 to the power negative 6.65. The negative in front just means get rid of the negative. Right? So that's one way to think about it. The other way to think about this is, remember the log has the property that if you have a log of a power, the power pops out as a multiple. So this is the same as 6.65 or negative 6.65 times the log of 10, and the log of 10 is always 1. Because this says, what power do you need for 10 to get 10? Well, 10 to the first is 10. And then we get that negative 6.65. And then our formula also had a negative in front, and a negative in front means basically multiply by negative 1. So that's kind of the arithmetic that's going on. So this problem is doable without a calculator just because we're using a base 10 there. If that wasn't a base 10, we're out of luck. So just by looking for the next problem, since they're telling me, blow this up a little, the H is 10 to the negative 13.2, then that means the pH must be 13.2 or 13.32. This one's 6.65. If you have any doubt, just plug that number right there into the formula. And remember, log base 10 is the same as log without a base. So on the calculator, I would just type what is the opposite of the log of 10 raised to the power negative 13.32, or whatever number you were given, and the calculator says, oh yeah, it's 13.32. All right, so next one, blood has a pH of about 6.68. Now, given the relationship that we see here, so I just want to write that down on my screen on a new page. If I put this in a table where I have pH versus the concentration of hydrogen ions, H, The concentration of hydrogen ions for the first one was 10 to the negative 6.65, and the pH was 6.65. That was, I believe, for water. All right. Water, tap water. And then the next one was bleach. So bleach had a concentration of hydrogen ions of 10 to the negative 13.32. And its pH is 13.2. In the next problem, we're given it kind of the reverse. We're given the pH first. So we're told that blood has a pH of about 6.68, which is pretty similar to tap water. Sorry, wrong button. So 6.68. Get that right. Where's my screen? There. Yeah. So then if I look at these the way they're related, then the hydrogen ion should be 10 to the power negative 6.68. So let's just compare that to the formula. The formula again said plug in the concentration of hydrogen ions to get the answer. So on my calculator, I take the opposite of the log of 10 to the power negative 6.68. It should say the pH is positive 6.68. So that would just be my answer for the value of H, the concentration of hydrogen ions. And the hope was after the first two, you recognize the relationship between the power of 10 and the pH. And so the relationship I see here is that the pH is the opposite of the power, oops, opposite needs another P, 10 of H. If you wanted to be more specific about what H is the concentration of hydrogen ions. So that would be a pretty good sentence if I could spell concentration. What's wrong with you? There we go. Is the relationship there.